Hello, in this video we are going to discuss about atomic force microscopy, or it is otherwise known as scanning probe microscopy. And this microscopy, atomic force microscopy, is a very high resolution type of scanning probe microscope that can work more than 1000 times better than the optical diffraction limit and can imaging, measuring and manipulating matter at the nanoscale. So it can be called a scanning force microscopy. So atomic force microscopy is otherwise known as scanning probe microscopy or scanning force microscopy. Main principle behind this atomic force microscopy is that in this method a laser beam is focused on the back of a cantilever and that moves up and down on the surface of a specimen, and the deflections of the beam are captured by a diode. That's the main principle behind this atomic force microscopy. So I will repeat this. The principle behind this atomic force microscopy is that in this method a laser beam is focused on the back of a cantilever that moves up and down on the surface of a specimen, and the deflections of the beam are captured by a diode. So here we can see the atomic force microscope consists of, in this picture we can see here the AFM consists of a cantilever. Cantilever is actually the conventional probe, cantilever. So that cantilever consists of a sharp tip at its end, which that sharp tip is known as probe, with which the specimen surface is scanned. So atomic force microscope consists of a cantilever with a sharp tip that is known as probe at its end, with which the specimen surface is scanned. So cantilever is normally made up of silicon or silicon nitride with a tip of radius of curvature on the order of nanometers. When the tip is brought into proximity of a sample surface, forces between the tip and the sample lead to a deflection of the cantilever. So that's what happening here when the tip is brought into proximity of a sample surface. The force between tip and the sample lead to deflection of the cantilever, and the extent of interaction between the tip and the sample, which is of the order of nanonewtons and is measured by cantilever displacement. So cantilever displacement is mainly monitored by reflection of a laser from the back of the cantilever and detected on a segmented photodiode detector. So the image is generated from the interaction force mainly. So here we already studied the principle of this AFM, where laser beam is focused on the back of the cantilever, and that laser beam is deflected and captured by diode, and the up and down movement captured by the diode mainly there. So the image generated here is due to the interaction force, interaction between the tip and the sample. So in this scan, if the tip is held at a constant height, there is a possibility of the tip colliding with the surface and causing damage. Hence, we used to adjust the tip to sample distance to maintain a constant force between the tip and the sample. So mainly AFM in atomic force microscopy, we can say sharp probe moves over surface of specimen at a constant distance, and there is up and down movement of the probe as it used to create image, and is mainly used or to analyze soft surfaces with supported liquid bilayers and can be visualized without damaging them. And also atomic force microscope provide a three-dimensional surface profile, and the samples viewed by AFM do not require any special treatments that would change or damage the sample. That's why this AFM used to study biological macromolecules and even living organisms. So it can be used for the investigation of binding between molecules like proteins, single strands of DNA or cellular receptors, etc. And AFM is commonly operated in two modes, contact mode and non-contact mode. So in contact mode, the uh, con- contact mode, uh, the tip comes into contact with the surface, we can say. But in non-contact mode, uh, it is actually the decrease in the amplitude of the motion when cantilever comes close to the sample and is used to measure the tip sample interaction. So non-contact mode is the gentle mode of scanning that does not damage the material. So non-contact mode is the mainly used mode. That's about atomic force microscopy. So in atomic force microscopy, you have to remember the principle mainly so that you can write the instrumentation part. Thank you.